So, equivalent ratios. Anyone want to talk me through? So, Corin, give me a ratio to start. 5 to 3. Okay?
And you could time 5. I mean, yeah, 5.
So, to find an equivalent ratio, I'm going to do 5 times 3 to 3 times 3, which would give me 15 to 9. Okay? So, we've basically multiplied by 3 of them. Okay? Is that the only way you can find an equivalent ratio? Can you divide as well? Could you give me an example? 6 to 10, okay? So 6 divided by 2 to 10 divided by 2, and you get 3 to 5. Okay, so we can also divide. In this case, we divide it by 2. What would the times by 3 be called? So what we did was we are going to find common multiples. Yeah. What we did there, or in this case, we divided by a common factor. Now, if I said to you, can you justify why those are equivalent? Is that possible?
So we divided if you times it by 3, we'll get 6.
Yep. So if we just did the reverse, we would get it. Okay. I'm thinking, is there any image that we could draw or something that would really show me that those ratios are equivalent? You may not picked up on this. This is what I'm thinking. Okay, I'm going to go with this one, 6 to 10. I am going to draw 1, 2, 3, 4, 5, 6 on one side, and on the other side I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a ratio of 6 to 10, right? Okay, now you may well spot where the 3 to 5 comes in. Yeah. So 6 to 10, we could say, is 2 lots of 3 to 5. So we can think of it that way. 2 lots of 3 to 5. Right? Now, can we remember, or maybe it's the next thing we're going to look at, what does it mean to have a ratio, like in a real world sense? Has anyone got an idea where ratios might be used? Pardon? I would argue not, actually. No, because the reason why, could a football score be 3 to 5?
Yeah.
3 to 5. But does that automatically mean it would then be 6-10? No, it would be 3-6 first, yeah? Is 3 to 6 equivalent to 3 to 5? 3-5. Ah, no, the biggest number doesn't have. I did quite like here. You see that we've got 5-3.
Yeah.
We've got 6-10. Larger, smaller, smaller, larger. Now, I'll bring other people in. It's an interesting one. Do we consider football scores to be ratios just because they write them kind of like it? Why not? Well, let's have a look. Let's consider another couple of ratios. Let's say we've got a ratio 1-1. What does that actually mean? Abby? They're equal. What are equal?
The two. No.
Two numbers. Could we apply those to anything? So if we applied it to football and goals, what does it mean? It would mean that Fulham have got 1 and Arsenal have got 1. But what's an equivalent ratio to 1-1? 2-2, 3-3, 2-2, 3-3, 4-4, and so on, yeah? Because this is 2 lots of 1-1. This would be 3 lots of 1-1. This would be 4 lots of 1-1. But is that what the score's always going to be?
No.
No. Because if it was a football score, what will happen actually, we don't even start at 1, but let's say we did. The next would be 2-1. That's it, but let's assume something changes. Are those two equivalent? No, and I think you can think of it by, well, when it's 1-1, it's a tie, like you said, but when it's 2-1, someone's winning. Yeah? So they're not equivalent because you can think a tie and someone winning is different, yeah? In the same way, let's say we've got 3-1. Arsenal, Man United. Alright? What would be an equivalent score to 3-1? 6-2. Alright? Because we have 2 lots of 3-1. But in a football score, do we go straight from 3-1 to 6-2? No. No. We don't do that. Right? And it's when we have equivalent ratios, we always have to maintain the same situation. So football scores, I hope you get this, don't quite, just because we write it like that, doesn't quite show us, because it doesn't behave in the same way. Right? Something that I'm thinking of that behaves in the same way is if I work 1 hour, I get paid $10. Yeah? So let's just think about that. If I work 1 hour, I get paid $10. So we could write that as a ratio, 1-10, yeah? What if I worked 2 hours? 2-20. Would it ever do anything different than that? Yeah, unless I got a raise, but let's assume I don't get a raise. It would then go up in that ratio always, wouldn't it? It would be 3-30 and 6-60 and so on. So in a ratio situation, what we have is, we could say it's got a constant relationship. And in a football match, it doesn't really do that, because a football match, you might always be winning, but you could be drawing, the other team could go and win. So although it looks like it's a ratio, it's behaving. All of those then are equivalent ratios. And we can justify it because 2 to 20 is
Oh,
2 times 1 to 10. 3 to 30 is 3 times 1 to 10. 6 to 60 is 6 times 1 to 10. Okay? So as long as we can show that all of those ratios are multiples of one single ratio, we know they're equivalent. I think you all probably got that in your homework, like in your criterion B, you've all seen that. Cool. Did anyone give me another example of a ratio in real life? Yep.
we have like a portrait or something, we might have like 6 apples and like 5 oranges.
But how does that go up then? So what would that say? So true, isn't it? Yeah, I think you're right there. Apples and orange trees, we could have a ratio which was 3 apple trees and 6 orange trees, but ratio of apple to orange trees, if it stayed the same, every 3 apple would be 6 orange, but we tend to plant apple tree. What if I do that, by the way? Let me just ask you a question. I'll come back to you. Okay. Let's say we've got an orchard which has apple trees and orange trees. I can't remember the first time I saw an orange tree. It's coming from England, there's frozen then. Let's say I've got 4 to 3. So, like Ryan was saying, that is a ratio, yeah? But what if I plant one of each tree? What would that ratio be? If I plant one of each tree, it would end up being 5 to 4. Here's my question. Are those two ratios equivalent? There was a bit of both, now it's more no. Would anyone like to justify their answer? No.
Fives are smaller. And
I
fours
know what you think, I like the way you think it. Yeah. So he's justified it in a way, it's not quite what we were talking about before, but it does work, I know exactly what's going on there. I think what would you say? Okay. Is there anything we've just talked about recently that we could use to justify it? Okay.
and 3 and 4.
Do they need to be? 3 and 4 are just how many apple and orange trees I've got. Those two numbers, it doesn't, I can write any two numbers I like there, 4 and the 3, it can be anything. What's important is the 5 and the 4 equivalent to 4 to 3. Well, we can multiply something by 4 to get 5. It's actually, anyone know those? Yeah, well done.
Wait, we're not doing this.
Yeah.
Oh.
So that's the question. So this is interesting. So if we times by 1.25, 1.25, we do get 5. Well done. The question is what you were saying. Do I get 4 if I times by 1.25? What do you get then? Can you work that out? Some people do, they're losing concentration. I think you should pause, notice, ask yourself, are you on track? Have a think where you are. So I've asked you to do something for me. Are you doing it? Then the calculators out are doing it. What is 3 times 1.25? Have it? It is 3.75. Okay? This is not 4. So we can say these are not equivalent. And as a couple of you said, it kind of makes sense because 4 to 3, it just, I don't know, it's just a feeling in my head. 4 to 3 feels like a bigger gap between the numbers than 5 to 4. And then 6 to 5 is an even smaller gap, you know? And we could look at it in football score. 1-0 seems like quite a big difference. Yeah, exactly. I like that. If we went all the way up to 100 to 99.
1% of it. So think about a circle and there's only a tiny slip.
Yeah. Now I like the way you visualise them. 4 to 3 seems quite good, quite big. Elani. Just checking that you're facing. Okay, so that would be quite an interesting way, not very mathematical as such, but for you in your head to go, alright, so those are not equivalent. Abby, you were going to give me another example of a ratio in real life. What? Yeah. Grapes.
Yeah.
Yeah. So watermelon, 1 watermelon, and it's the amount of money, yeah? How much does 1 watermelon cost? Cheap, man.
You wish.
You wish in Bermuda.
Maybe like 11?
Should we do 15 bucks? Therefore, 2 watermelons would cost you 30. Yeah. That's one thing. Do we always just double it? Okay, because this is 2 lots of 1 to 15. This is 4 lots of 1 to 15. And what have we missed? 3 lots. So quite often people only double, and they miss a load of equivalent ratios. I was thinking of baking.
Oh, yeah.
Why is baking ratio related?
Four cups of sugar and 5 cups of
Wow, what are you making? Yeah, I get it, Yeah. Yeah.
recipe. It's not a recipe on like they'll say this can like make this many.
Yeah.
It should be like this amount of people have.
Yeah, you've given me a couple of options now, which is if you have 5 cups of salt, you want 4 cups of sugar. So if I want 10 cups of salt, we need 8 cups of sugar. As Owen said, if this recipe is for 4 people, but I've got 8 people coming, you double it. Now this is probably going to be a piece of work I'm going to get you to do, which is changing the recipe.
5 people. Don't tell her.
You didn't do it last time. You didn't cook anything. You didn't put anything in. It was it. It was Austin brought some stuff in. I mean,
The same amount of this to this. If you add 1 to normally this, then you add 1 to that.
and does it make sense? So, for instance, if I am making a cake and it calls for 10 cups of flour and 1 cup of sugar, and I add 1 cup of flour and 1 cup of sugar, does that make sense? because that's doubling my sugar, but not doubling my flour. So I'm definitely going to change the recipe, right? It's not going to work. I don't know whether you've ever tried it. You know, oh, just more chocolate, put more chocolate, and it ruins it because of the chemistry of baking. Right. I don't want to talk too much more. So the other thing, what was the other thing in our objective? We just so let's just check then that you understand what simplest form is. Right? It's not lowest highest factor. You're close. Go for it. Not far. Okay. So if we've got a ratio such as 10 to 15, we are going to find an equivalent ratio. So when you find equivalent, you either multiply or divide, yeah? We've talked about adding, and therefore subtracting doesn't work. So we are going to divide by the highest common factor. The lowest, highest common multiple of factors. Yeah. Highest common factor, we're going to divide by the highest common factor. So what is the highest common factor? So the HCF of 10 and 15 is 5. How do you know it's 5? Well, that's kind of it, isn't it? Just have to know your times tables. One of those things, isn't it? And then we do 10 divided by 5 to 15 divided by 5, just like we were doing with it. It's just an equivalent ratio, but ends up at 2 to 3. This is simplest. And I will say there are no decimals. No decimals in simplest form. There are decimals in a different form, but we're not going to talk about it here. Yes, Owen.
Get the factors negative numbers.
Yes.
This is like the same as you have negative.
Question. Did you get what else? Got negative numbers still have factors, don't they?
But if you were baking,
Well, that's another thing, isn't it?
this.
Do negative numbers relate to ratios in real life?
Then how about
Potentially more difficult. That's why negative numbers are seen as a little bit more difficult than positive numbers, just because how do you apply them in real life? So we would have to have things like, are we talking about financial debts? Are we talking about the depth of how far underwater we are? And even then, I could just say it's a positive number and I say underwater. You know, I'm 5 meters underwater. How does anyone dive? Or with your air tanks and things, there's a ratio, right? How much oxygen you carry to how many minutes you can spend in it. And doesn't it change if you go deeper?
yeah, you take
So the ratio changes. So you could argue that that's a negative as you go further down.
also
You don't that's why I see it.
they take small in, try not to remove any.
So with diving, there's lots of ratios and lots of impacts on those ratios that you. So if you breathe at the same rate and you're at the same depth, the ratio can stay the same. As soon as you go deeper, the ratio changes. If you are less fit and you breathe, that ratio changes again. Anyway, two things, equivalent ratios and simplest form. Do I need another example of simplest form? Well, let me give one. There is just one I want to ask. Write 1.5 to 7 in simplest form. Because I said there are no decimals in simplest form, but I didn't want you to think there are never decimals in ratios. Because if I go back to baking, you can have 1.5 cups. Yeah? But it's not what we call simplest form. Anyone got any ideas what we can do there? Well, if we add, we're changing the ratio, right? So we're not going to add. So that's just one decimal. I get what you did. Did you divide it by 2? Yeah? But that just gave us more decimals.
The only way to get rid of it is if you add.
It doesn't know. If you oh no, hang on.
Oh yeah.
You didn't add then, what did you do? No, that's not it. He did
I did that. Wow.
multiplied. We stuck with multiplying. What did he multiply by?
2.
2. Okay? So the numbers have got larger, but it is simpler because there's no decimals. How do we get rid of a 0.5? Well, hopefully you would understand that 0.5 is the same as 1/2. Well, that's another technique. You could have gone up to 15 to 70 and then back down. But remember, if you add 1.5, you would have to add, that doesn't work. Exactly, that's what I'm saying. That's why you didn't add, because remember we do the same to both numbers. If we add the same to both numbers, it doesn't quite work. Yeah, 3 to 14 is the correct answer. Well, what's 1.5 times 2? It's 3. So you need to hopefully know how to multiply a decimal up to. Okay, I've got 2 options for you now. In your textbook, practice 1 on page 11. I'll show you that now. It's not you. Here, look. Simplify the ratios, write 3 equivalent ratios, and then the more important ones, the level goes up, the worded questions, they're super important.
There's a lot.
Now, I mean, there is a lot there. I would suggest most of you are going to go with it, because this will be the kind of thing your assessment criterion A will look like. However, some of you might go, I'm fine with that, I'm going to challenge myself further. So on Teams, I have set a transfer task. All right? And the transfer task, let me see. Oh, I closed it all down, unfortunately. The transfer task is on Teams. There you go. It's ratio. Click on that. Now, level 1 is really easy. Time for you to wake up. Level 2, simplest form, but then it goes quite quickly into putting it into other things like decimal fractions, that kind of thing, it gets harder, and then it goes into sharing fractions, with sharing ratios, which we haven't done yet. So I would suggest to start with, you do practice 1, starting on page 11. If you're thinking, oh, that's all just a bit easy, feel free to have a look at the practice task, but check in with me first that there are 2 options. Okay, first option, second option, and that will take us, well, into next lesson because we don't actually have anything. I'm going to pause the video.